You guys are not able to hear me. All right, guys. So welcome back to the series on NLP, guys. And agenda for today will be we'll be starting with first. I will quickly make a recap on the sentiment analysis for the engineering feedback. Yeah, guys. Good afternoon, everyone. And let's get started because we have a lot to discuss today. Yesterday, we were able to see how we can perform a real-time sentiment analysis, right, using the machine learning algorithm, right? And we were able to understand that how to collect the tweet, how we were able to perform the movie sentiment analysis, and we were pretty much clear that how we can perform this task, how we can clean the data, how to perform text pre-processing, how to bring this data towards a certain format, so it will be consumed by our model. So this was just the beginning, guys, and we were able to understand that how we can perform all this kind of activity in the machine learning and what are the basic concepts. On top of our knowledge, today we will be trying to understand what is recurrent neural network. And once we understand what is the recurrent neural network, we'll also try to understand what are its implications, what are the techniques in the neural network, recurrent neural network, and what is called as the famous concept called as LSTM. Why we use LSTM, what is the issue with the recurrent neural network, how LSTM is helping us to improve the recurrent neural networks in consistency. And then we'll try to also discuss today two more case studies. One will be we will be performing a fake news classification using LSTM, and then I will try to show you word embedding. What is word embedding and how it is different in the context of the recurrent neural network. TF-IDF, guys, TF-IDF, you already know that what are the limitations with the TF-IDF. All those sort of concepts we'll try to understand when I'm trying to understand the recurrent neural network. What is the issue? Why we need this kind of recurrent neural network? All those stuffs we'll try to understand today. Okay, before we go into our topics agenda, let's have a quick look at this project of the sentiment analysis based on the students' feedback for engineering, right? So this is the project I want you guys to perform, and for that purpose, there is the already ready-made code which I have created, and there you guys will be able to understand looking at the code only. So it is not that different. Whatever use case we have different, it was about the movies sentiments, and this will be around the student sentiments, right? So let's get started. Let's try to understand. I will not do entire deep dive into this topic. I'll try to give you just the overview, so you guys will be able to understand, and you have to do the similar thing. The code will be same, everything will be same, only the data will be different. Okay, that's what will be the difference. All right, so without wasting time, let me close some windows and get started. Okay, guys, what we have to do is this entire project has been based on the feedback which has been received and which was collected in terms of the Google form. This how I will try to show you how the Google form look like. What the people did is they went ahead and just wanted to create this kind of Google form, and on basis of this Google form, they created some survey. Okay, on the basis of this survey, they were able to understand. Okay, let's have a look at the Google form sentiment analysis for student feedback, and they have a course code, then the feedback, and the sentiment, what they think, right? Positive, negative, neutral, whether they are having any previous experience or knowledge in the subject area, what is their gender, and also the attendance of the students, like whether there are regular student, irregular student, occasionally they are going to the colleges, right? And what they feel from their point of view, that what is the course difficulty, all right, and the average number of spent hour for studying, right? It should be between 0 to 24, each and everything, and how they think that is what is their overall satisfaction level on the numerical scale. Here we are asking on the basis of the overall sentiment, and here we are asking in terms of the numerical scale, right? Between 0 to 1, and whether are you a 300L computer engineering department. You can change this question, guys, department question accordingly, and you can circulate this kind of form. Once you are able to circulate this kind of form, right, then you will be able to have a data with you, along with you. And once you get the data, we know already, right? What are our steps? Our step is to first, whatever data we are receiving, once the data is received, we'll perform all those tasks which we have seen, right? Tokenization. We'll try to tokenize these things into the words. Then we'll do our text pre-processing in terms of the stop words. And first and foremost thing is to bring them to the lowercase, right? Lowercase, then stop words, then punctuation marks, right? If you still feel that is there any other language detection, you can do language detection as well. Then according to the language detection as well, you can perform this kind of stop words cleaning, punctuation marks cleaning. If you see that there are any apart from this stop word, there are any irregular words, right? Irregular words, those also you try to remove them. Then you try to make them in the form of stemming, because we understood stemming is more fast than lemmatization. And once we are able to do stemming and lemmatization, then comes the part of the word to vector, right? Word to vec. And once we perform this word to vec, then we'll be able to get a score of, like, let's say TF-IDF. TF-IDF, a kind of matrix which will be giving you the scores on the basis of the words, right? Or different words, and then it will be consumed by your model. In this case, we used the Gaussian naive-based model, right? Multi-Gaussian naive-based model, multi-normal Gaussian naive-based model. So you can use this one, or you can also use whatever ensembling technique we have used. You used the boosting technique. Using the boosting technique, we were able to use the decision tree, right? On the basis of that, we were able to bifurcate our overall sentiment, right? Overall sentiment. And also we'll try to perform simultaneously the EDA part as well once before we even set up this model, right? So these are all the steps which just wanted to show you guys that what will be the steps you will be taking. All these steps are covered over here. It is pretty much simple. These things have been already been shared with you guys, right? These things are already shared, so I will not go into detail. I will just try to give you a quick overview, so you guys will be able to get a hint of it, right? So let's get started. First, you will be importing all the important libraries, stop words, TF-IDF, vector, count vectorization, right? Cross validation, grid search CV. Grid search CV is also used, guys. It is one of the important algorithm, right? Grid search CV is one of the important algorithm to perform the fine tuning, right? Fine tuning of the parameters. So using which you can be able to understand what kind of parameters, like how many decision trees to be used, how many models to be used, what will be the minimum leaf node, maximum leaf node, how many, what kind of splitter should be using. All these stuffs I don't want to go into the detail because you guys are already having some background in the machine learning, right? So that for that purpose, in order to understand the best parameters, we'll be using the grid search CV. Once we are able to understand, then we are having also label encoder, multinomial, naive Bayes, accuracy score, and pipeline, right? Pipeline, like I showed you yesterday, just apply all the techniques simultaneously using the pipeline, and you will be able to fit the model. So this is how the feedback looks like, guys. This is the course code, feedback, previous experience, gender, attendance, whether they are regular, course difficulty, what they feel, how many hours of study they have done doing per week, then overall satisfaction level, numerical scale 1 to 10, and department and other information, right? And then we'll try to perform all the cleaning stuff. Then columns, like remove the white spaces, right? str.strip, remove the white spaces, drop the unnecessary columns, time stamps, right? They are trying to change the gender to LGBT community to male for that purpose, but it's up to you that how you want to change the columns and all. Then they are trying to look at the data frame, right? Data frame, how it is looking, what are the data types they are having. Then they will be doing data processing or text pre-processing, like converting to lower scale, right? Converting to lower scale, then trying to remove the punctuation marks, then try to tokenize the things, and then lemmatization also, wordnet lemmatization, and then they are trying to apply it, right, on the basis of that column. And then they will be detecting the language. Same steps, guys, whatever we also seen yesterday with terms of the movie sentiment analysis for the Abir Purish movie. Same steps they will be doing, right? And then feature engineering, if they want to apply any special methods on like splitting the things and all, right? Sorting the values and then looking at the data, how it looks like. And then they're trying to we saw yesterday, right? Sentiment polarity using the SI, sentiment intensity analysis. Using this, we were able to get the scores and overall sentiment, whether it is positive, negative, and that kind of stuff. Because we initially did not have the labels about the tweets, right? So we have to use this SI technique, and using which we will be able to get the scores, and on the basis of these scores, we were able to generalize the sentiments, right? And this is what they are also applying over here. Then the mean, median, mode, count, right? Value counts, everything, all these steps of the EDA, right? Try to analyze how the things look like. Then they're also trying to check the frequency of any specific words or phrases in the feedback, right? Because they want to understand, is there any particular word which is coming up? You can use a word cloud also, like we've seen, or you can use this kind of technique also to understand the frequency, right? Then trying to cluster the similar feedbacks together, right? They're using even, as this project is very special because we are not only using text processing, text pre-processing, right? Pre-processing, and we are also not only using classifications algorithm. We are trying to also use the ensemble method, and they are trying to apply a semi-supervised, let's say, semi-supervised methods over here. Semi-supervised method means it is a hybrid approach. We are using unsupervised approach as well as the supervised approach, right? Because they're first trying to create some sort of clustering, right? Using the k-mean clustering, they're trying to understand or trying to bifurcate the feedbacks, right? In terms of the clusters, and on the basis on top of it also, they're trying to analyze the things like providing the algorithms on top of it, right? So this is a very crucial step, guys. This is how the real-time work will look like, because in real time, we will not be using only one application or one kind of algorithm at a time. We'll try to understand from all the angles, all the EDF point of view, all the feature engine point of view, that how we can make it in more practical way, right? That's how the topic modeling and latent this LDA technique, guys. If you want, you can skip this one also. That's because we have not spoken about the LDA topic. Later on, I'll try to show you, like they just to give you the hint, like this code is very simple, that they are trying to apply just the latent direct allocation, and on the basis of the different features we are having, right? Clustering are formed. Okay, they are trying to form the cluster to understand, guys, to any specific feedback is arising in a particular cluster, right? They want to cluster their group of people, and then in the basis of this cluster, they want to analyze even how the sentiments look like. For that purpose, they are trying to perform this kind of clustering, right? If they try to cluster on a basis of cluster 0, cluster 1, cluster 2, and among that clusters, they wanted to understand what are the feedbacks. So that could be one of the techniques, but it's up to us, like how we want to use. And then, like I was trying to tell you, that these are the important topics. Like LDA is the like topic modeling. Just simply to summarize what they wanted to understand. They wanted to understand that as any specific top words to retrieve for each topic, right? And if you see all the instructions are written, all of the instructions are written here, so you will be able to understand even looking at the code that what we're trying to achieve. So they want to understand, is there any special words are arising for any particular topic? Let's say topic 0, 1, 2, 3 is nothing but the group of topics or documents, right? And within that, what are the top feedbacks for that topic modeling is concerned, right? So they are also trying to do, this is a new technique which we yesterday did not look at it, right? Topic modeling. So this is topic modeling is just simple thing, guys. You will be able to understand by looking at the code and by using at the different topic, what are the keywords or what are the important words where we can put a stress on it. That kind of things they are trying to understand. Then they are trying to understand the emotion, polarity score, and everything, like we did yesterday on the tweets. And then on the basis of that, they will be doing EDS. They weight cloud, like we understood yesterday, weight cloud, and then the correlationship matrix. Then the same thing which we are seeing, like pie chart, creating a pie chart on the basis of this polarity score and overall sentiment, which we used SI techniques from the pre-processing and this SQL, sorry, not SQL, analytical library, right? And then gender-wise bifurcation and everything. Then count of feedbacks, like how many distribution of hours and everything. And then also they're trying to understand, is there any kind of outliers present or how we can deal with this, and then distribution of the data. And then in the end, they will be applying the modeling. Okay. I'll try to show you the model. They're trying to apply entire scatter matrix. On the basis of that, they were trying to analyze the correlationship among the data set, right? So everyone aware of these things. Then they're trying to perform the trend test split, then count vectorization, transforming the things, count vectorization, using the count vectorization, then applying the multinomial naive Bayes, because we are having more than two categories. That's why you are using multinomial Gaussian naive Bayes technique. Okay. And then they are also trying to apply a ensembling method called as XGBoost classifier, which is using around like 80 trees. If you look at this parameter, they are using 80 trees for that purpose. And they want to understand that if you look at this parameters, guys, try to understand these parameters. Why need a grid search CV? This is one of the algorithm which is used to perform the hyperparameter tuning, right? Hyperparameter tuning, hyperparameters tuning, right? And what kind of hyperparameter tuning they are looking for is like what could be the learning, like maximum depth of the trees, how many trees they should be there, what kind of encoding should be used, how many classes are there, and then there will be one more technique like splitter, right? Splitter, whether do you, which kind of splitter do you want to use? Also, there will be called something called like minimum sample leaf, minimum sample leaf, minimum sample leaf node, minimum sample leaf nodes. How many should be the minimum sample in the leaf node? How many child's nodes should be there, right? Minimum, that kind of all this. I don't want to go into detail. All these stuff everyone has learned in the machine learning, right? Whenever you try to put this kind of trees, we will be having a splitter also. Splitter is like how you trying to perform a root node. On the basis of the root node only, then you will be further splitting them into the child nodes and some other nodes, and then there will be leaf node. And how you will be using the splitting, right? Whether you are going to use the method of entropy or whether you are going to use the Gini index, right? Gini index. So all these stuffs, these are the parameters using which all these parameters, right? All these parameters has to be fine-tuned. For that purpose, we use this kind of algorithm, grid search CV. There is one more algorithm called as random search CV. Random search CV is there. Both are working in the same way. You have to just pass this kind of parameters to this algorithm, and along with the range of these different values. Let's say if this is the parameter number of estimator, how many decision trees we want. So you can pass like 80, 90, 100 or some range like from 80 to let's say 100, right? And that kind of stuff you provide, and it will be able to give you the best parameter, best underscore parameters for which you will be getting the highest accuracy. Okay, highest accuracy. What is the objective? Okay, guys, the objective is to understand that whether whatever courses are taught over here, right? Whatever courses are taught, whether the people are liking those courses or not, or other, or what are the important topics, what are the important topics or words which are arising out of these feedbacks, right? Out of these feedbacks, so that can be inculcated to improve the courses, right? That is the main aim over here. So that's why they are trying to perform the analysis, guys. I'm not asked. I am asking about the parameter XGBoost classifier. Okay, guys, XGBoost classifier parameter you are asking. Okay. See why we need this parameter, because again we want to perform the classification, right? Classification, and for the classification, in order to make it correct, right, we are trying to choose the parameter. That's it. XGBoost classifier. Whenever you try to set this kind of model, for that reason, multi softmax. Okay, objective multi softmax. Okay, that objective you are saying. Okay, guys. Softmax, multi softmax objective means they're trying to understand that what kind of probability function you will be using, right? So usually we use sigmoid function, right, in order to create the probability. But since this is a multi-class classification, we cannot use the sigmoid function. For that purpose, they are using softmax function. Softmax function will be able to give you the probabilities for different classes, right, between 0 to 1. Sigmoid will not be able to perform that when we are having a multiple classes. So in multiple classes, we cannot use sigmoid function. So we can use this softmax function. That's the whole reason. Sorry, guys. I was not able to understand in first place what you are trying to ask. Okay, this is how we will be doing. No, guys. This is not in ANN. That's not the agenda. That we can use it here also. See, we have used it, right? Softmax. So we can use it here also, which is activation function overall. So you can use it anywhere. Hyperparameter tuning, grid search, right? Grid search CV, I told you. And on the basis of that, we'll be creating the exhibit classifier. Then pipeline, I told you, pipeline, which is the processor you will be using, model, and then or the parameters, and on you will be able to fit the parameter. And then once you are able to fit the parameter, you will try to check the accuracy. What is the accuracy? What are the depth parameters, and how we are trying to achieve the accuracy, right? And then once we achieve all these things, guys, they have created a very beautiful dashboard on the basis of which they are trying to communicate on. This is created in the Power BI, guys, but you can create over here in this EDA section only. Okay, try to have a look, like how many feedbacks were received, how many total courses were taken into consideration, what is the average per feedback, overall satisfaction level, average study hours, right? And all this kind of beautiful visualization has been created, and this kind of report you should be able to submit to your management, guys. Yes, guys, I will be sharing entire this file. This file is created specially for you guys only. I'm not going to keep this file with me because you guys have to do this project for your respective colleges. So that's why I will be sharing this on priority today itself. Okay. And how to create is like you can use the same. This is nothing but the graph side, guys. Try and understand. This is pie chart. This kind of is a horizontal bar graph, right? And this is also a horizontal bar graph. And whatever summary, whatever summary we have created, right? Whatever summary is created, this kind of boxes you can try to print using our normal visualization packages, also using Matplotlib, Seaborn, or some other techniques where you will be using this kind of visualization. You can create a similar visualization, okay, using the using our normal machine learning techniques as well. Yes, guys, I will be sharing all the files on entire presentation, whatever presentation I am taking. All these files will be shared, okay? And this is nothing but, again, guys, this is nothing but the stack plot. This is basic we have used. These are the basic stack plots which are used in the Seaborn as well as the Matplotlib libraries, okay? This is already a stack plot which is there in the Seaborn as well as the Matplotlib package, right? The same, this one is also a line chart, right? They are trying to create a line chart. So don't go by fancy things, guys. This is just they have created a beautiful visualization and they are created using Power BI. That doesn't mean that you will be not able to do it using the Python. You can use it Python. You can use a Seaborn package. You can use Matplotlib, right? And you can use some other packages as well, whatever you feel comfortable. And the basic, even you can use it using the data frame. Let's say Pandas library also. There are certain plots are available. So you can make use of it, but most popularly use Seaborn and Matplotlib. All these packages are available, okay, in there. And you will be able to create this kind of graphs. And this weight cloud we already discussed. This weight cloud, this is called as weight cloud. We already discussed. This is nothing but a pie chart, which you can be able to, you will be able to see it over here. The code and everything is already generated here. Just they are trying to see this kind of graphs, all pie charts and everything. Already we have discussed all this stuff in the EDA part. Okay. So what you have to do is collectively you have to create this kind of graphs and try to print it separately, then try to take a screenshot of it and try to paste this as a picture. So why you need a visualization tool, right? You create these separate graphs, try to paste that graphs on any Word file, and they take a screenshot and put a punch in this screenshot over here. Okay, how to create a Jupyter notebook BI report? Okay, please show heat map, guys. I would love to show this heat map and everything, okay, but this is very basic, right? This is very basic. You can go through it. This heat map and everything, you can go through it. That's not a difficult task. Okay, whenever you try to understand this graph and everything, when you will go through codes line by line at that time. Okay, the coming back to the question, guys, how you can create this kind of graph, right? How you can create this kind of graph in Jupyter notebook, right? In Jupyter notebook, what you can do is like here, if you come here and you instead of code, try to select this as an markdown. Okay, once you hit a markdown, then you will be able to insert here. Insert image, right? Insert image will be created and you can insert the images of graphs, whatever you created, right? And using that, you can punch in this kind of graphs over here. And then I already told you guys how to create these graphs is just go ahead and do the EDA part using this Seaborn and everything. Okay, using Seaborn package and using this Matplotlib package. Okay, Matplotlib package, and then try to create individual graphs like pie charts, stack plots, line charts, right? Summary boxes. You can print the summary boxes, confusion matrix and everything, and then try to place them in a Word file or any other Excel file or a Word file. Like in the Word file, you will be putting all these kind of summaries, right? Whatever graph is there, take the screenshot, put in this grind of graphs over here, and then take a image out of it. Try to create image by using print screen. Guys, to create a BI report, it is not a specific code, right? You have to use the external tools. No. You don't have. Yes, you can take a use of the BI tools, guys. That's okay. But you can create a similar graphs over here. Okay, there is no collective, like there are also automated libraries. Okay, what you are seeking for, I can understand. There are automated libraries are there. Automatic EDA perform like yellow library is there, yellow bricks or something library is there. Then AutoML is there. AutoML is one more library, and there are also other libraries like I'm not able to recall the name, which can create this EDA part for you guys automatically. EDA part is automatically created. Okay, yellow bricks. I will try to share these names with you guys, that what are the packages. Like AutoML is there for sure. Then some yellow library is there, yellow, and some name is there. And then so there will be one more, 2 to 3 libraries are there, right? So using which all these graphs and everything, you just provide the data. You just provide the data, raw data to them, and it will be able to create a graphs for you guys. You don't have to do any coding or anything. All this stuff is taken care by these packages, right? All these AutoML packages, they will try to create all these graphs for you guys, right? You don't have to create, and then you can just punch in these graphs here. Okay, guys, most popular. Yeah, if you did not get any material, guys, if you are not able to get any material, you have to get this material from the LMS, right? We already seen on day one how to check the material, where to check and everything. Go back and please have a look at that video, right? That video is already uploaded. You can go and check, and even if you are not able to get it, you can go and check in the YouTube as well. This has been done. And then popular algorithm, I will be telling you guys what is the popular algorithm. Email notification request access. Guys, if you have any queries regarding LMS, or you are facing any issues regarding the LMS, Amar, please put it the email ID for our support team in the common chat box. So people will be able to address their issues on that common email ID, or where to get a contact. All the contact ID will be shared by my colleagues, guys, Amar. And you can direct your queries to that email ID or that support email box, or the support colleagues are there. Okay. EDL@excelr.com, guys. This has been the ID, EDL@excelr.com. EDL@excelr.com. Whatever issues you are facing regarding the LMS, or you are not able to get any access, or you are not able to view any material, you are not able to create account, or let's say you are not able to create any login for your particular courses, please try to get in contact with the EDLR@excelr.com, this email ID, and also the colleagues will be supporting you. Okay, don't worry about it. All right. And the popular algorithm, guys, try to understand that popular algorithm for NLP are in the deep learning. Okay, in the deep learning, because nowadays, rather than machine learning, because machine learning also useful when we are trying to perform a sentiment or text analytics, and that we are popularly using the ensembling techniques, let's say random forest, decision tree, or any sort of algorithm that is not a fixed algorithm, but we are using naive-Bayes algorithm mostly. Naive-Bayes algorithm works very fine. Multinomial neighbors, if it is many classes algorithm, it is binary class, then normal class, normal naive-Bayes algorithm. Okay. And for this kind of algorithm can be used in the machine learning. For the deep learning, we are obviously using the recurrent neural network, RNN. Within the RNN, we are using LSTM. We are also using, mostly use word to wake method. That I will try to teach you guys. Don't worry. Hold on your horses for the moment, but I will try to teach you whenever we are trying to complete all these things. Today itself, I will be able to show these things, that which algorithm to use, where to use. So try and understand that recurrent neural network is mostly used for the sequence data, where sequence means kind of a text data, which is again a state of art algorithms are there. So algorithms are available for NN, like LSTM is there, then transformer is there, then BERT is there. Okay. Bidirectional encoding representation for a transformer. All these stuffs are there. Okay, guys, CNN, try understand. Very good question. Convolution neural network are used for the image processing, image and video processing, and whenever you trying to create an or extract any features, okay, extract any features from these images or videos at that time, or you want to perform any segmentation, image or video related stuff, and all this stuff. At that time, you are using CNN. Convolution neural network means you are trying to extract from image. From image, you trying to extract the different object detection. Let's say object tracking. Okay, object detection, object tracking, image classification, video or image understanding. Okay, all these stuffs we are using convolution neural network. And for recurrent neural network, I will try to discuss. Don't worry, I'm going to switch to a recurrent neural network only now. We'll try to understand in depth intuition what is recurrent neural network, why it is used, what are the techniques in the recurrent neural network, how the entire working looks like, right? All these things. I didn't get what is PSO, guys. Can you just elaborate? I'm not able to understand from this one. Okay. I hope you guys understood what you have to do, right? In terms of this project. So this is the entire code base, guys. You just have to change the data and try to execute the different methods. Okay. Change the data, use this Google form, then try to change the data and try to perform this project. Optimization with PS algorithm. That will try to understand, guys. Don't worry. It is not possible, guys. Try to see the limitations also. We are conducting this for just only 1 week. If you are interested to learn so many things, you can again come back and contact us. We'll try to arrange this kind of sessions. Okay. So within 1 week, we have trying to cover all this stuff. So we have certain limitation, because usually whenever we are trying to understand, like on day one only, I have told you what is the entire roadmap, right? At that time, around like, let's say it takes around 50 to 70 hours to understand end to end each and everything, right? All right. I hope, guys, just quickly give me the confirmation. No, guys, it is for 1 week only. So okay, we cannot extend. Maybe we'll try to set up new sessions, this kind of NLP series. Maybe we'll call it as series 2.0, right? Series 2.0, where we'll be starting with more advanced techniques. Okay, that could be also possible. All right, guys, just quickly ping me that. Are you now comfortable how to perform a sentiment analysis on the student feedback for this your respective colleges? Entire code is given, right? Quickly ping me. I will try to share this notebook and presentation as well with you guys by today itself. So using this one, you can perform this project. Try to take some time, have a look at it, right? Have a look at the stuff, get acquainted with the code, try to run this code individually on the Jupyter notebook and try to implement this. If you are able to implement, guys, try understand. This project is production grade project, right? What do you mean by production grade project is, if you try to showcase this kind of project, it is a real-time product. It is a real-time product and can be directly consumed by any application. Okay, can be directly consumed by any application, which can be generalized and which you can call it as an emotion analyzer. Or that sort of stuff, right? This is end-to-end code, production ready code, right? We was only thing which is remaining here is the API thing and all that you can understand later on. That's not a big deal. That, by the way, in every company they have like ML ops team, ML operation team, just like the DevOps team, and they will be taking care in the background all the stuff, right? So this is again a very beautiful case study, guys, and it was very popular a month back in the community, okay, machine learning community and data science community. So purposefully I have taken these things. I hope that you guys are now able to understand the entire use case and what are the expectations from this project and what is your role, right? What you have to do. All right. So guys, just quickly ping me few more confirmations. So let me switch back to my presentation meanwhile. We'll try to start today with the recurrent neural network. Right. Guys, can you just confirm that you are able to see my presentation so we can go ahead and start understanding recurrent neural network? All right, guys. Thank you, Balaji. Thank you, Rajaswi ma'am. Thank you, Dina. Let's get started, guys, without wasting time. So try and understand that we are now done with, guys. We are done with the machine learning. Now we wanted to start the NLP with the deep learning. And in deep learning, especially whenever we are trying to perform the task like the text processing or some sort of NLP related task, at the time, let's imagine that you want to perform any kind of NLP related task. That task requires some sort of special understanding, right? Special understanding and special understanding of the sequence data. Okay, so for that sequence data, this RNN comes into the picture. So with just I will not go directly into the RNN, but try to understand that why we need RNN, what is the human analogy, that how we try to understand the sequences, sentences, languages on the basis of that thought process. Okay, try to understand that how humans think, how humans understand the language, how humans try to interact with each other, right? Like semantic representation or semantic analysis, it is called as, right? Semantics means nothing but try to understand the sequences, right? Try to understand the sequence or try to understand the meaning or representation of the meaning, right? And then that is done on the basis of the semantic analysis, right? Whenever we try to, if you look at this picture, right? Whenever we try to understand with the human brain, let's take example of human brain. Whenever we try to analyze anything or try to understand the information, how it is done, we first try to obtain the data, that data is processed, and then we trying to understand the sentences, right? Or whenever we are doing listening actions, right? Whenever we receive a brain signal instruction, accordingly we are trying to create the things, right? Like muscle movements and all these things. If you find a pattern or try to understand the things, that there is a chain, right? There is a chain related to each other. This action which is performed at time t has a back connection with this kind of state, right? T minus 1, and even this T minus 1 has a connection with T minus 2 or T minus 0 somewhere right here. So entire thing is connected to each other. That means there is a sequence which has been generated, and using this sequence, all the actions are performed, right? Whenever we are thinking, right? Every time whenever we are thinking or we're trying to perform some kind of speech, right? Or whenever now even I am giving you all this presentation, are we trying to understand about the NLP algorithms, right? NLP algorithms. Are we starting from the scratch, guys? No, right? Every time we are not going back, like what is the first thing we understood, right? We understood all the concept of text pre-processing and machine learning. Now we are able to generalize on the top of this knowledge, right? On top of this knowledge. That means what? I have a certain basic understanding. On the basic understanding, I am now try to analyze the information, right? Now I'm trying to analyze the information. We are not starting from T0, right? Every time we are starting some middle layer, or maybe a particular layer where it is just adjacent to the recent time, right? Just adjacent to the recent time. And on the basis of that situation, we are trying to understand the things, guys. Okay. Whenever we read a sentence, whenever we speak the things, right? Based on that words, we try to understand. And whenever we try to understand, even for every word, there is certain prior knowledge, right? Prior knowledge is expected. And on the basis of that, we are trying to perform this kind of speech recognition, or what people are saying, how to reply them, right? And the same thing they're trying to adopt. Okay. Like whenever we talk about the artificial neural network and how they have been adopted into the machine learning, that they're trying to mimic the human neural networks, right? Humans biological neural system, right? Biological neural system. They're trying to mimic the same thing and the similar concept, right? So for the CNNs, convolutional neural network or artificial neural network, they adopted the visual part, the visual cognition process, right? Visual cognition process. Now, and if you remember, guys, in the brain, there are 4 parts. Whenever you try to look at the brain structure, there are 4 parts. Out of that 4 part, like the back side of our brain, on the back side of the brain, there is one part called as cerebral cortex. Cerebral cortex. This cerebral cortex, guys, is responsible for the visual recognitions. For the visual recognitions, right? For the visual recognitions. Whenever we try to look at any picture, or through the human eyes, whenever we are trying to look at the things, right? We are trying to look at any things, any picture or anything, then this cerebral cortex will come into the picture, and within this cerebral cortex, right? through this eyes. Okay, this is our eye. The image is received and then it is processed layer by layer. Layer 1, layer 2, okay, and then layer 3, and then there will be parallel layers like L5, L7, L6, and then it will be reaching, and then there will be firing of the neuron, and the basis of that will be performing the actions. Okay, so this is how the works in the biological. This is not the biology class, I can understand, but try to understand the resemblance, guys. What is the resemblance between the human thinking? What is the resemblance between the human neural network? The similar they are trying to mimic, and for recurrent neural network, they are trying to mimic something called as semantics analysis. Semantics analysis, right? So in semantic analysis, they're trying to process the data, or they're trying to understand the things which has to be do with the sequence processing. Okay. And in order to perform this sequence processing, it require a reference. It require a reference to the previous state. And that cannot be performed by the CNN or normal ANN, guys. Because in CNN, ANN, we do not have the reference to the prior network, or we have, I can understand, you will again ask that, even we are having this kind of connection, right? Whenever you try to create you will see, all of you might have seen, right? Let me draw it in proper way. All of you might have seen that this kind of neural network is there, which are all these things are connected, right? All these things are connected, but try understand that whenever we are going from input layer to hidden layer, and from there to output layer, at that time, what is happening in forward propagation? They're just trying to apply the summation function and activation function of the weights and inputs, right? Weights and inputs, activation of summation of weights multiplied by the input. That is what is happening. And they are not storing any information. They're not storing, or they do not have anything called as memory. Okay. So they are not storing, they're just trying to process in backward propagation. They are trying to understand, update the weights. All these weights are updated. On the basis of that, we're trying to find out our parameters, update our parameters, which is weights and biases. And on the basis of the weights and biases, on the basis of this algorithm, gradient descent or optimizer, right? This optimizer, we're trying to reach to a global minima, and we are trying to find out the derivative with respect to loss. All these things I'll try to discuss with you whenever we're trying to discuss this forward propagation in terms of the recurrent neural network. But try understand the logic, or understanding that whenever we're trying to deal with the sequential data, it requires some sort of reference, and that sort of reference or that kind of thinking can be done using the recurrent neural network. So without wasting time, let's move ahead and understand that this recurrent neural network are the family of neural network which understand the sequential data. Okay, now I am trying to say every time whenever I am talking about the recurrent neural network, I am talking about sequential data. What do you mean by sequential data? That I will try to understand also, but try to understand or imagine that how the things are working, that what is the overall level of understanding behind the recurrent neural network. Okay, whenever a person asks that what is your opening hours, right? So we are trying to understand the intent by looking at this question, and then we're trying to boost our understanding and reduce the error. Then we are trying to extract the entity we spoke about, named entity recognition, and all these things we have already spoke upon. Whether I am trying to talk about any particular place, whether I am trying to talk about any particular object or any particular thing, that is entity, right? We are trying to talk about the entity. When we are trying to understand intent, what is his intent, what he's trying to ask, what he is aiming to ask, that we trying to understand using these sentences. We are trying to understand, make it process like we are doing the text pre-processing, and then we trying to extract the entity. On the basis of that, we are trying to give a reply, right? This is what is happening in terms of the chatbots, the advanced chatbots or advanced neural networks which are working in terms of the NLP, right? So this is the process, entire process is happening, but in terms of the artificial neural network, that is not possible, right? That's why they have created this kind of neural network which can deal with the natural language processing and the speech recognition. And that is how this RNN model is designed to understand the sequential characteristics of the data and use the pattern to predict the scenario. Okay, so that is what the recurrent neural network does. So it understands the sequential data, understand the pattern. That is what is happening over here. This pattern understanding, entity extraction, and then it is trying to reply, right? So let's try understand what do you mean by sequential data, or why this recurrent neural network are there. What is their thoughts? Why should we use recurrent neural network, right? I understand. Sequential data means what, guys? This is the example of the sequential data. When I'm trying to apply information with regard to the time series, let's say I'm trying to predict the stock prices, sales, right? This kind of information or this kind of task, right? It requires the understanding with respect to the time back propagation, right? Time back propagation. That means what? If I want to predict any sale at the for the next period, right? I need to consider back, go back to the time, or let's say I have to look at the last 6 months sale, last 1 year sale, and then I will be able to make a decision on that, right? Or maybe able to do the prediction. So for that kind of series, like time related tasks, like stock price prediction, sales prediction, or any demand forecasting, any sort of things where we are trying to predict the things with respect to the time, or even try to predict the temperature or any sort of things, whether there will be cyclone or not in this year, right? And that kind of stuff. Where what could be the rainfall this time, all these things, or whether we are dealing with any manufacturing industry or anything like sensor data, like signals, voice, handwritings, right? Text, whatever texts are there, we trying to identify the label and test sequences. Or and like we understood sentiments, we are trying to perform the sentiment analysis, right? We trying to make a summary of the text or trying to translate the text, or speech recognition, speech translation, right? Machine to machine translation, speech recognition, all these activities. Or let's say you are giving image or video data and they are trying to create the captions or labels out of that data, right? Let's say this is the image, and this in this image I will try to create a person, and this person is trying to play some instrument. Let's say this is a guitar, and then he's trying to play this guitar, right? Pardon me for this bad picture, guys. I can understand this is very bad, but let's try to make understand that his person is playing some sort of instrument, like playing some sort of instrument, and then I provided this image, and then it will be able to generate a text for me that the man playing guitar. Okay, that kind of task, all right. All this kind of task is called as sequence data, right? Sequential data. And for that purpose, we require this kind of recurrent neural network. Understood, guys? Action recognition, machine translation, question answering, chatbots, right? ChatGPT. What is the ChatGPT? ChatGPT, this is the popular buzz, right? This is nothing but a question answering what sort of things, right? But it is trained on the large language models, which are also based on the recurrent neural networks, or some not of vanilla flavors, but some sort of advanced recurrent neural networks, or some sort of architectures of the recurrent neural network, which are based on the large amount of the data, right? And then they are trying to give you question answers. That's what. And this they are fine-tuned on the basis of the prompts. Prompts is something like whenever we are performing human to human interaction, at that time we'll try to create that data, right? Whatever the dialogues data is there, that kind of data is created, and that data is understood as a corpus for our model to perform the training, right? And that literally the humans are speaking the whatever the text is generated of the interaction, human interaction, right? Human interaction, or that data will be provided as a corpus to our machine learning or sorry, deep learning models, and on the basis of that these are able to understand. So okay, so try understand that whenever we try to speak about the recurrent neural network, there are certain limitations with terms of the artificial neural networks and in terms of the convolution neural network, because of which they are not able to understand the sequential data, right? Sequential data, or whenever we are trying to perform any sort of text analytics, which requires a reference towards the certain previous state, right? Where we are not able to have any kind of memory of the previous state. But in recurrent neural network, we're trying to remove this kind of gap and trying to process the sequential data, right? And that is why recurrent neural networks are playing very crucial role. I understand, guys, what is happening over here. Okay, so whenever we are trying to understand that, we already spoke about there are the limitations, and then whenever I can try understand that what is the limitation. Okay, very biggest limitation. Let's imagine that I am trying to perform an emotion analysis or sentiment analysis, right? Sentiment analysis. Again, what kind of data I am receiving? I am receiving text data, right? The text data consists of the sentences. These sentences, let's say, I liked the food, the service was also good. So what is happening when I am trying to give this as an input, right? Input. Imagine, let's say the length of my sentence is having like around 100 words, or let's say 50 words, and such 1,000 or 10,000 sentences, right? 1,000 or 10,000 sentences I am trying to provide to a neural network. So imagine what kind of huge neural network will be created, right? If I am going with this artificial ANN, this kind of artificial neural network, I will have to create thousands, and again that means layers of the hidden neural network, right? Then I will be providing the only single bifurcation of whether this is positive or negative, right? And that kind of complexity it will be creating when I'm trying to use artificial neural network, right? Or any, for that reason, any CNN neural network. So in order to avoid that, or in order to avoid that kind of complexity, right, very large and growing neural network, the RNN helps us. Because in RNN, what we're trying to understand is, I'll tell you what we're trying to understand. And again, try to take understanding of our previous example only. Okay, this is how the typical recurrent neural networks look like. Okay, or first I will try to give you two examples, so it will be very clear for you guys to understand what is a recurrent neural network and how it is performing the task for the sequential data. So let's take one example, that let's take example whenever you are trying to watch a movie, right? Whenever you're trying to watch a movie, and if you're trying to watch a movie right in the beginning, right from the beginning, right? Beginning of the movie, at certain point of time, you will be able to predict, right? I think all of us have seen or experienced this kind of thing, that whenever you try to watch a movie, and based on your past experience, right? Based on your past experience, whenever any new movie you are trying to watch, and you will be able to predict, okay, at certain point of time, you will be able to predict what will be the next action or what will be the next scene, guys. Guys, can you just ping me simultaneously that have you guys ever experienced whenever you are trying to watch a movie, that what will be the next step or what could be the next scene that you would have already imagined based on the movie you are seeing, right? So try to ping me simultaneously your thoughts, okay? So I will be able to read your thoughts as well, right? So whenever we are trying to look at a movie, let it be any complex movie, Hollywood movie, action movie, romantic movie, but since we have a good corpus of our imagination, thoughts, or cognitive process, that whatever a movie is there, and whenever you are trying to watch, at certain point of time, you will be able to predict what could be the next scene, what could be the next action. I know that's how they try to make a turning in the movies, right? Make a turning in the movies. But hero always wins the action movie, correct, guys? Or what happens is, nowadays in typical Bollywood movies, right? In typical Bollywood movies, in the end, whatever the matter, but all the hero and heroine, they will end up with having a happy life, right? A happy married life. So this is not the reality. This is never the reality and never had been a reality there, right? Even this is a hypothetical situation, but on end of the day, they are trying to show you a happy ending, right? Happy ending or something sort of that stuff. But in reality is very harsh, right? Reality is very harsh, and this is not happening in the reality. So, but imagine, but you are not, since you are watching a movie right from the beginning, at that time you will be able to predict what will happen next. And imagine someone came after, let's say, 30 minutes of time, 30 minutes of time when the movie started, right? After the movie started, if you ask him what could happen next, maybe he will not be able to predict it very accurately, right? Very accurately. That accuracy will be very less. Accuracy, because we are not having the background, or he is not having the background or a memory of what has happened previously 30 minutes, right? And that could be the information. What is happening actually, guys? Try to understand why I'm trying to give this kind of stresses. The chain or the sequence is broken. Sequence is broken, right? If you miss the previous episodes, if you try to miss the previous movie scenes and all, the chain your chain is not created, right? Or the sequence is not created. So that means what? In order to perform this kind of task, you require a certain chain or certain kind of sequence, right? If you are able to understand the sequence, you will be able to perform the task, right? So, or try to take example, we have learned now in machine learning how to perform the sentiment analysis. In machine learning, what we are trying to do, we are trying to tokenize the data. We're trying to tokenize the data, and then whatever the text pre-processing is there, we are doing, I mean, steving and everything. Then we're trying to perform the word vectorization, right? How we are trying to perform the word vectorization? Maybe encoding, and then TF, IDF, TF, IDF, or we are trying to do a bag of words. Okay, bag of words. Yeah, bag of words, n-gram, scriptgram, word to vector, count vector, vectorization, right? This kind of stuff. But imagine when you're trying to process this data, scriptgram, correct guys? Scriptgram, right? Scriptgram. Whenever you're trying to do, let's say I am trying to take example, same example, okay? Yes, guys, C1, everything, correct. You guys are already intelligent. Let's say whenever I am trying to take this information, right? Whenever I try to this, there is no sequence, or whenever I try to create this kind of matrix, right? In this matrix, the joint word is there, movie word is there, he is there, being is there, ask is there, right? And on the basis of that, I am trying to create the scores for them. 0 0.5, 0 0.25, 0 0.10, and let's say 0 0.05. That kind of stuff I am trying to create for particularly, and I am trying to create a vector, numerical vector out of it, right? But where is the sequence, guys? Where is the sequence here? I am trying to lose the entire sequence because I am trying to bifurcate this word, right? These words are bifurcated, tokenized, but I don't see any kind of chain reaction over here, or any kind of sequence which is pretend over here, right? We are losing all this information, whatever is there. We're just trying to understand that information. On the basis of that, individually, we are trying to perform the classification, okay? On the basis of the scores, we are trying to create a numerical score. On the basis of that, we are putting a condition if the score is like there is 0.25, greater than positive. If it is less than that 0.5 or minus 0.5, it is negative, right? That's what we are doing. Or if it is not, doesn't match anything, let's put it as neutral. That's it, right? Where is the sequence? But there is no sequence, right? So that kind of sequence is some sort of task, like we discussed this in movie. Or let's understand even a task like whenever you're trying to speak to any digital assistant. In that case, let's say Alexa, right? Alexa, whenever you're trying to ask anything to Alexa, Alexa, go to YouTube and then play this romantic movie, top 10 romantic movie song, right? So these kind of things, right? We need to have a sequence, because Alexa has to understand your intent. It has to process the information. Then accordingly, you have to give the answers. If Alexa just says that whatever movies you are asking for, it is just saying that here is the list, go and play yourself, right? This is not happening. So this is a good example, guys. Recurrent neural network. The Alexa is trying to understand your emotion, your intent, and then it is trying to give you a fulfillment. Or for that reason, understand the Google search as well. Google search, whenever you are doing a Google search and we are trying to understand or put any text, right? This text is created. That text is now created to graph theory. On the basis of that, it is trying to retrieve the images, and then again back it is showing you all the results, guys. So in the background also, they're trying to apply the recurrent neural networks. This is again example. And again, what is the issue? To understand that in machine learning, let's say you're trying to process a time series data. Okay, time series data, and we already know the popular algorithm like ARIMA. ARIMA model is there, SARIMA model is there, SARIMAX is there, SARIMA is there, SARIMAX is there. All kind of these flavors are of all this algorithm. What they do is, let's say you have to predict the any point of time what will be the sale or predict the price. At that time, they're trying to take a certain period of window of time, right? Window of time, and then they have to predict the things, right? Predict the prices or predict the values, right? Or predict the sales. But in recurrent neural network, gives the flexibility to look at the entire data set, and then on the basis of that, it will try to give you a prediction. Okay, that is the beauty of the recurrent neural network. And this is how a typical recurrent neural network looks like, guys. Can we say recommendation also work on the basis of RNN. No, guys. Recommendation also use kind of RNN, but let's understand that for recommendation system, there are different altogether different algorithms are used. In recommendation system, just quickly I will try to tell you, and then I will try to move because we have to within 1 hour we have to discuss many concepts there and very interesting concepts, right? Recommendation system works on certain things like content based, okay, content based, then collaborative filtering, then knowledge based, and then one typical hybrid approach is there, hybrid approach which use the deep learning artificial neural network along with this content let's say content filtering or content based knowledge collaborative filtering, content based collaborative filtering, okay, and this knowledge based, okay, this kind of algorithm, and along with it try to use the reinforcement learning algorithm, RL. So this is the combination which has been worked in the background in order to perform the recommendation system, guys. Okay, recommendation system, that is again a different topic. We will not to understand. That is what they use. Okay, whenever the recommendation or you are trying to understand that whenever we are trying to predict the next word, what will be the next word in this sentence, or whenever we try to perform a summarization task, okay, summarization task for this entire graph, or whenever we trying to let's say generate any text, at that time the recurrent neural networks are working, okay, always. Or whenever you try to convert the text to video, text to image, or whenever let's say you are trying to create a music, your input is music, and on the basis of that it is able to create a new music. All this types temporal stuff, right? All this stuff is recurrent neural network. All right, guys. Having said much, try to understand this is how the typical recurrent neural networks say look like. Don't get confused. I will try to tell you what looking at these things. In very typical artificial neural network looks like the horizontal one, where we are having this kind of inputs, x1, x2, x3. Then we are having the hidden layers, and then we are having the output, right? And this shows something like horizontal one. And this is how goes by width and become very deep. So that's why we have to use this kind of vertical stacking or vertical shape of things. Okay, because what is happening whenever I try to create any sentence or emotion analysis, within one sentence only I will having like around 100 to 50 words, and all this has become a 50 inputs that will be going into, right? So I at that time imagine what kind of complex structure I will have to create, right? For that purpose, what they're trying to do is, and when we are trying to also process this kind of sequential data, what they're doing is typically they are giving input. For input, let's say I liked the food. Okay, I like the food. So this third word will be I, which will be going. Now, obviously, there will be some weights assigned to it, and then it will be going and processing these things in the neuron. And on the basis of that, they will be generating some kind of output, let's say H. Okay, whatever output is created, but it is happening with respect to the time, guys. Whatever happening is with respect to the time. Again, let's say t at the rate output as the rate t1. Okay, I just gave it at the t1. This is just the single input, guys, single sentence. Then I went into the neural network as an input, just first word I liked. Then out of that, it assigned the weight. It was processed. It went to the, let's say, activation function, and again, and with the activation function here somewhere, it will be also having a input, additional input, which is the output of the previous cell. Let's say t0. It is starting with the t0. At that time, it will be having an input as t0. T0 is nothing but initially it will be zero padding or zero matrix, right? Zero matrix will be there. Then I will try to understand one by one word, one x1, x2, and x3, and let's say x4. These are my words, and these words are I liked the food. Okay, I like the food. I'll try to drop this one to make it better. So first time x1, this is x2, this is x3, this is x4, this is how it is going. it is going assigned with this weight. Okay, and then it will try to perform multiplication operation, and then it will be giving you output at the right time t minus 1, t1. Okay, this is t0, this is t1, and then again the same weight is used, guys. Same weight is used again. The next time the input x2 will be going, x2 will be going, then it will be passed on, and whatever is the output of this one, let me rub and make it very clear. Okay, first time the x1 is going. I'll try to show you guys when I try to unroll this thing. I'll try to unroll this entire concept, but try to understand in general what happens is whatever inputs are going, their inputs are assigned with the weights, and when even the previous state is taken into consideration, then the vector output is created. Again, whatever is the output is there, it is processed for the next time, and along with the same weights, whatever weights are there, that's also maintain consistency. And this is how the entire things will be going on for x1, x2, x3, and x4. Okay, this is how it will be going on, and this is how this will be one single iteration will be happening. Then it will be moving to the next sentence. Try to understand this difficulty, right? Yeah, guys, I understand this is a heavy one, but try to understand there are many concepts which we are going to understand. Okay, so let's move to it's what you can say is like this will be the good example. Okay, that what I'm trying to tell you guys. So when I am trying to unfold this entire thing, this is how it will look like. Let's take example of this one. Okay, this is how the recurrent neural network typical cell look like. Okay, recurrent neural network always thought of multiple copies of same neural network. Guys, I'm trying to put in the simplest word all the information, all the whatever, even whatever I am discussing right now. Right. Apart from that, within the slides, I have put in a explanation in such a way that even a people without any background, okay, without any background of the artificial neural network or any machine learning neural network, if you try to understand or concentrate, you guys will be able to understand the things. That's why without just feeling the too much information, I'm trying to give more or more pictorial representation. Okay, more and more pictorial representation and trying to explain you the guys. Once you are able to understand what is recurrent neural network, how is the process happening, that's it, guys. Then you can build any sort of architecture which are very complex, like LSTM, by LSTM, okay, transformers, attention models, BERT, then comes the GPT. Okay, this kind of things will be able to you guys will be able to understand. So try to concentrate just for 5 to 10 minutes. Please try to concentrate, guys. What is happening? It is difficult. It is not difficult. It is somewhat different, and we are trying to deal with the timestamp of the data. Okay, time is introduced here. Time is nothing but again what is happening is whatever input we are giving at first time, then whatever output is generated, that output is also taken into consideration, guys, for the next iteration. That is what is happening. That's why it somewhat looks let's say complex, but it is not complex. I understand. The recurrent neural network, what happens is it is a multiple copy of the same neural network. Each is passing information to a successor. Means what? If at time t equal to 0, if I am processing this thing, whatever the output is there, that will be passed on to this thing, and again there will be second output taken, then again it will be processed, then output 2 is generated, output 1 is generated, output 2 is generated, output 2 is again passed to next layer. Next again, guys, don't get confused that I am trying to perform different neurons. It is the same hidden layer. Just I am trying to bifurcate or unroll it. Okay, this is what is happening inside this neuron. Okay, inside this one hidden layer. This is just the single hidden layer. Okay, H1 only. Within that, inside it, this kind of operations are happening. Because why this kind of operation happening? Try to understand. Because we are trying to pass one sentence as one input, right? At a one input which is one sentence, and this one sentence contains of this kind of words, right? These words. So these words are going one by one as an input, and they are getting assigned. And now I'm talking about the sequence, right? Sequence means whatever words we are trying to understand, we have to create a chain, right? Sorry, we have to create a chain or create a relationship with all these words. Then only it will be making some sense, right? When I'm trying to analyze this sentence. So that's the reason that this kind of operation is happening. Okay, this is a typical RNN cell where first what happens is this is my sentence. Out of this sentence, the is going. This word the is going. The is going first. Then this kind of, and let me tell you what happens. There is a two-step process happens always, right? In step 1 and step 2. This is same with the artificial neural network only. In step 1, it is try to sum all the weights and multiply with the inputs, and then it is passed through activation function, right? Let's say this is a F. This is F, where we are trying to multiply the weights with the inputs X, right? And this is passed to the activation function, which is in turn giving you value between 0 to 1. This is the two-step process happens always. This is what is happening over here. Two-step process. Whatever weights are there, these are same. These weights are same. And then whatever outputs is coming, O1, O2, O3, and O4, these are respect to the time now. With respect to the time, like time t equal to 1, t equal to 2, t equal to 3, and t equal to 4. So I'm just consider the four words. If it is consists of, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, then there will be 10 such layers, 10 such things. Okay, 10 such operations, not layers, because this is the single hidden layer. And then with this hidden layer, guys, try to understand, may consist of hundreds of neurons. This could be hundreds of neurons inside it. Okay, thousands of neurons. Okay, this could be thousands of neurons inside it, and within that, this kind of operations is happening. What operations are happening? It is taking one by one word as an input. Okay, this word is taken as an input, and this two-step process is happening. Step 1 and step 2 process. I will try to keep this here. This process, which is summation of the inputs into weights, and then passing through the activation function. Okay, activation function. All these things, which in turns giving you the return in 0 and 1. Okay, this is what happens. That's why we are saying that whenever we are trying to unroll a RNN cell, this cell, okay, this is typically a cell which consists of various neurons. There is no limit. Whatever neurons you want to take, you can take this kind of neurons, and these neurons will be passing on, and then it will be giving you output. Again, this output, like this one, I gave this word D, that went through the neurons, it processed the weights, like this weights. Okay, this weights, and this will be the another weights. Okay, whenever this output is going to next one, let's say that weight I am calling as W dash. Okay, W dash, and this one W. These W weights are assigned every time. These weights are same. Try and understand, guys. Weights are same. They are not changed. These weights will be changed, updated only in the back propagation. In the back propagation, in forward propagation, this is happening. Okay, so they are trying to take the inputs one by one word at a time. It is passed to a neuron. Then neuron, the typical two-step process is happening, step 1 and step 2. And whatever result is there, that result is called as now here H0. Then H0 is now passed here to next cell. Okay, within that next cell, what is happening? Again, there is an input X2 is taken. X2 is what? Over here. Okay, X2 will be diagram. Okay, next word, the diagram. Diagram will be coming over here. Then it will try to perform again the two-step process, and then it will be giving you some input. Then output, that will be called as H2. Again, that will be passed. Again, it will be multiplication of X3 into same weight. It will be processing, and this is how it is going on till the time we reach the last word. Okay, guys, this is how the recurrent neural network cell look like. Okay, don't get confused. It is very simple. Only what thing is happening is, instead of showing this individually operation one by one, it is trying to fold it. And that is the advantage. If you are trying to make a simple neural network, imagine it will go on depth like thousands, right? If you have a 10,000 words, imagine what kind of complex architecture is happening. And plus, they are not having reference like this one. This references is there, right? This reference, this output, whatever output is there, it is passed on here. Whenever we trying to understand LSTM, I will try to again show you whether how the memory cell is created, how it is able to understand the sequential data. Okay, but for the basic understanding, try understand this is what happens. We try to take the output, again the same weights, initialization, activation function, then giving the output, and then this is what happens. How many times it will happen? Till the times we are having all these words in single sentence. Okay. No, guys. if the activation function is tan h and the weight is same, but the whatever information there, that will be not same. How it will be same? Because we are giving different inputs, right? These different inputs. That's why the weights will not be same. Sorry, weights will be same, but the output will not be same. Okay, they try to create this kind of things. Okay, guys, cool. Understood what is the RNN, how the typical cell look like, and what are the operations are performed within RNN. So let's try to go forward and try to understand the things. Okay, so this is what the typical things happening. We already discussed that whenever a new state is created, it consists of the previous old state, right? ht minus 1. Whenever I am getting a new output, which is considered of the function of ht minus 1 into input vector xt. What is input vector in xt? Let me tell you again, same thing. Okay, ht minus 1 means what? Whatever output is created. Okay, h1 is the output created over here. This h1, this output is again passed on to next layer. Okay, where I am taking an input as x2, and then along with it the weights, and then the two-step process happen, activation and multiplication of weight into input, and then it is trying to give you the output, right? This output will be like h2. That's how h2. So that they're trying to create or try to show you over here, right? By using the same thing, that a typical new state ht consists of the previous state t minus 1. Right? If I am talking about this step consists of the previous input, right? Previous output, and then here the weights multiplied by the all the x, right? All the x inputs. This is what is happening, right? Output of this one, then weights multiplied by the inputs. This is the typical process happens. This is what they're trying to show. Don't get confused. This is very simple. If you very aware that what happens in a cell, summation of weights into inputs and then passing through the activation layer. This is what is happening. But what is the only thing, or what is the difference, that whatever the output generated, that output is also combined in the next operation along with this x2. If this is the x1 process and x1 is created output O1, that O1 is again combined O1, right? This is what they're saying, output 1, right? Output 1 into the current input x2 into the weights. That's what they're saying, right? So whenever I am trying to reach as ht depends on ht minus 1, old state. That is the output at t minus 1 and plus weights into input. That's what they're saying, right? This is what is happening. Okay, try and understand, guys. And whenever we are doing, let's take very good example I have to try to put in over here. Don't get confused with these buzzwords which are created like this omega of function ht. Nothing but that. Simple thing is to understand whatever the output is there at any particular timestamp. At any particular timestamp, whatever the output is there, that output consists of the function parameter, which is the function parameter of output of t minus 1 multiplied by the weights into inputs at a particular timestamp. X2 is the particular input at that time, whatever multiplied by weights, and that is multiplied by the previous output. This is what the only change. Previously, we are not having this kind of things, right? Output is not combined in artificial neural network. Here, they are trying to combine because we are trying to process the sequential data, and now we are trying to create a connection between the words or between sentences because our input is text. That's why this is happening. Let's try to look at this example. Movie, fantastic, awesome. Okay, this is the text I am trying to provide. What it will happen is that will try to create into the vectors, word vectorization. Now, whatever the dimensions are there, I will try to teach you everything, that how this word vectorization is created, or how we try to understand the feature representation. This dimension are shown in the feature representation right from the one-hot encoding. Using the one-hot encoding, we are trying to create a vector. Those vectors are now converted to feature representations. Okay, feature representation. That's what they're trying to show you. Try to understand. Whenever I'm trying to provide this kind of words, these words are vectorized. Okay, these are vectorized, and these are vectorized. Let's say previously I have a words whenever we trying to show, I will try to give you a simple idea. Whenever these words are there, they are converted to numericals, right? This word is created to numericals, and whenever they are created to numericals, let's say for every word there will be a one representation. Let's say word movie will be shown, movie will be shown by number 1, and then the fantastic will be shown by the number 2, and this awesome will be shown by the number 3, and so on. We will keep on going till the time you have mentioned the limit of your corpus or word, right? There's a typical word for it. That word, let's say word vector or vector length. This is the vector length, okay, 10,000. Let's say you are given 10,000 words, and then for the, let's understand it as a kind of a dictionary, right? It's a kind of a dictionary. So for every word, there will be a respective numbers, okay? For movie, for fantastic, and even for awesome, right? There will be number. All this will be converted into number in first step, and all these numbers again will be shown into the word embedding in terms of the feature. What kind of feature, that I will try to tell you. And once it is created, this kind of word embedding, that word embedding will be going to our recurrent neural network, like this one, this recurrent neural network, which consists of the different cells, hundreds of neurons. Within that, they're trying to perform this kind of operation, right? This operation, input, this kind of output, previous output multiplied by weights and the inputs. Okay, this kind of operation it is happening in recurrent neural network, and whatever is the output, final output, along with the activation function, let's say it will be created into a vertical stacking, right? Flattened layer. It is called as flattened layer. That flattened layer, why we have to create a flattened layer? Because in the end, we'll be using again artificial neural network to perform the classification, right? To perform the classification, that will be given to the fully connected layer. That artificial neural network is called as fully connected layer. So whatever output are there, we are trying to stack those outputs, the feature, and that will be passed to any classification algorithm, something like that. And then it will be giving you using the sigmoid 0 or 1 or any other activation function. So what is the negative or positivity of this particular sentiment, right? So hope this is pretty much clear for everyone that what is happening, what is the entire process whenever you are trying to pass a word, how it will be converted into word embedding, right from the one-hot encoding like dictionary type of words, from there to feature embedding to recurrent neural network. We have seen that how when we unroll this kind of stuff, what kind of operation happen. All that operations will be provided into the some dimension vector, and then all that vector will be again passed to some sort of, let's say if it is a multi-class classification, will be passing to the softmax activation function, and then it will be able to give us the prediction. Let's say prediction will be like 0, 1, 2, that is positive, negative, or neutral, or maybe 0, 1, positive, negative. Okay, that kind of stuff will be happening. Everyone clear what is happening here? Let's move to this. This is the typical representation, guys. How the RNN removes the complexity. Okay, this is a very beautiful representation given where you are trying to look at the different inputs, right? These different inputs are coming, and along with it, previous outputs are also going. Okay, by the way, this is the different inputs, and then on the basis of that, it is trying to create. This is a single or vanilla flavor. Okay, this is called as vanilla flavor, and this is a deep recurrent neural network, guys. Deep neural network will look like this one. We are having multiple cells like this, which are performing the multiple operation at a time. And this is nothing but one layer. This is the hidden layer too. Because we have seen in the hidden layers, multiple neurons, and multiple times with respect to the time T0, T1, T2, it is performing this kind of operations, right? And then whatever output is there, that is passed to next layer. So this is how the stacking or stacking of the recurrent neural network look like. Deep neural network look like this one. We are having a multiple RNNs, RNN1, RNN2, right? And this is a single RNN, recurrent neural network. All right, guys, please ping me if you have any questions simultaneously. I will try to move ahead because I know it is been late. We are already reached to 4:30, and I have to show you at least one implementation today. Limitation of RNN. That's what we're going to discuss, guys, now. Okay. So what RNN, let me go through this slide very quickly, that what is the benefit of the RNN. Okay. So it is help us to perform the processing of the sequences. We understood how the sequences, and no matter how long or how much depth of the sequences is there, practically without creating a complex neural network, it is trying to give us the same thing. Okay. And then the process has a variable length sequences. That means complexity do not vary even if we are trying to provide the 10,000 words or 1 million words, or let's say 1 billion words. In LLM, in large language model, we are providing 1 billion words, right? 1 billion data, that kind of data. So complexity not varying, okay? Doesn't matter how longer sequence is there, it will be able to reconstruct the neural network using the same thing, because we are using the same neural network again and again, right? We have seen. What do you mean by same neural network? This one, I'm trying to understand that the same thing is used multiple times, right? Multiple times with respect to different inputs. X3, X2, X1, X0. So that's what they're trying to refer over here. Okay. Whatever input is there, whether it is a longer sequence, whether varying input is there, and also how they are able to process the entire sequences. Okay. That is the three major benefits why we should use the recurrent neural network. So try understand, guys. So what is the forward propagation happening? I already put in entire information, but quickly I will try to go through it. But let's say I told you guys what is happening. Let's say this is the word. I liked the movie. So this is the one sentence which is going on, sentence one. And then this kind of hundreds of sentences may be there, 10,000 sentences there. So this sentence, I am doing a tokenization of the word. And this is how the typical X1 will be I, then it will be light, and this will be the movie. And this is what I told you. If you could remember the representation, it will be consist of different neurons. Okay, hundreds of neurons will be there. Then they will try to pass these weights. This is the multiplication operation happening, weights into multiplying the input. Then it is passing through the neurons, and then it has a reference to the previous output also. And then it will be typically creating the output 1. Then output 1 will have a W dash of weight, which will be again went into this consideration. Okay. And then again, the next word will be coming from here. Again, the same thing is happening, and it is try to create a output 3. Then output 2, and along with this W dash weight, if you see the weight is remaining same, guys, W dash, whenever we are trying to pass the information output to the next layers, next neurons, right? And then whatever weights are there in the background, okay, let me clarify the thing. Whatever weights are there associated with the inputs, they are also same, W, and here W dash. Okay, this is what the things are happening whenever the words are going on, and then they are trying to perform. This is called as forward propagation. How the forward propagation is happening? Let's understand. Output 1, I will try to make you guys understand this formula. Okay, output 1 consists of what? Okay, typically tell me, guys. Now try and understand this thing. This output 1 consists of what? X1. Yes, guys, correct. So X1, output 1, this is dependent on what? Weight and this input X11. Okay, so that's what I have written in what is happening. Input X11 into the weight, this weight. Okay, and then it will also depend on what? This 0. That's why I written O0. O0 is here, guys. O0. This is O0. This is O0. Okay, this is O0. Again, it is dependent on what? O0 and this weight. Okay, this weight. These are the 4 things it depends on, right? Multiply by weight, which is present over here, into input, plus the output of previous one, multiply by these weights. Okay, this is how the operation happening. Similarly, understood, guys? This is what the happening in forward propagation. Then it will be passed in the output layer, and which will be give us the prediction by head. Then we'll be able to calculate the loss. Okay, and then for the reference also, I gave you recurrent neural network image. That is what is happening over here. So again, try to understand the example O4. In O4, what is happening? O4 is dependent on, guys, the feedback link is same, guys. You can feel it. Again, this is not a different one. They're trying to again give it to you. Okay. So understand O4. How O4 is calculated? How O4 is happening? O4 is dependent on what? Is dependent on this weight and this X14. Okay. This X14 and W, and also it is dependent on what? O3 and this weight, right? This is what is written X14 into weight, right? This weight plus O3 into this weight, correct? This is what is happening. Okay, guys, understood what is happening in forward propagation? This is typically the entire process for the forward propagation looks like. Okay, let's go and understand the things that how the weights are updated and what is the issue with the weights. I'm not going into detail, guys, into the vanishing gradient descent and all this stuff. Now you need to understand in the back propagation what is the thing happening over here. Okay, so whenever I'm saying that there is updation of the weights is happening, so this is typically the same thing, guys. This entire thing is like forward propagation. Okay, this entire thing is forward propagation. Now once we perform the forward propagation, what will happen? We start with the calculating the loss, and we have to optimize the loss, right? Optimize this loss. Optimize the loss using the gradient descent, where we trying to reach to this minimum point where it is loss is 0. Okay, this is what, and we will be starting somewhere here. This is our weights. Okay, weights and biases. This is what is happening. I'll quickly try to tell you guys what is happening in the back propagation, how the back propagation happens. Okay, let's try to focus this on. Once I calculated the y hat, okay, after this forward propagation, then come to this place. Okay, optimize the loss. We have to optimize the loss using the optimizer gradient descent. What happens is you have to calculate the new weight. How new weight is calculated? Old weight minus learning rate, learning rate into derivative of loss with respect to weight, derivative of loss function, this loss with respect to this weight. Okay, this is what happens. Okay, and whenever I am trying to say this is first iteration, okay, this is the first weight which is calculated. When I am trying to calculate this weight, what will happen? Or try to understand the same weight y hat. If I am trying to write this double dash, okay, w double dash, this w double dash, if you see, I have given you explanation that this w double dash, whenever this weight is updated, what is the formula tippling happening? So we are trying to take a derivative with respect to the loss, right? With respect to loss of the weight function, the same thing again. This weight is dependent on what? This is dependent on y hat. Okay, and this y hat is again, let's say y hat is dependent on what? W dash, right? The previous w dash. So the same thing try to write the same thing, that whenever I trying to update this kind of weight, that weight will be dependent on y hat, and that y hat is dependent on the loss function. So we can go back reverse this way and try to understand how we can write using the chain rule. Okay, so loss, sorry, this weight we are trying to calculate. First we are trying to optimize the loss will be like dependent on the y hat, right? And this y hat, how we can write it? Again, this y hat is dependent on the weight. And that's why I'm trying to write the derivative of loss function with respect to this weight. And then same can be written again, how it is with respect to the y hat into w dash, right? Chain rule. I'm not going into detail. If I want to apply and multiply, but same thing, I can write the same thing again. Okay, I'm just trying to apply dy hat over here. I'm trying to multiply and divide. If you try to multiply and divide any term, the result will be again remaining same, right? Remaining same. This is how the typical weight updation happens. Let's imagine how this weight will be calculated. If this weight is, we have to update this weight, right? This weight we understood that depend on y hat, and this y hat depend on the loss function. That's how they calculated. That's how they try to calculate w hat loss function with respect to the weight, and this loss function in fact depend on the y hat. That is the prediction. That's what they're trying to understand over here. That's it. And then when we are trying to update the weight, which is remaining here, imagine how it will be happening. Okay, this weight, how I will try to write that weight is derivative with respect to loss with respect to weight, derivative of loss with respect to weight. This will be again dependent on what? Y hat, right? And this y hat is again dependent on what? This output. So that's what they are writing, dl by dy hat into dy hat divided by this output, and this output is again dependent on what? This weight. Okay, I know somewhat complex, it is chain rule, but whenever I am trying to update the things, okay, y hat, this y hat again depend on this, and this again depend on this output, and this output is depend on this. They are trying to create a chain, right? I will try to create different marker, try to understand. Okay, this y hat, this depend on what? This weight, right? This weight, sorry, this y hat depend on output. This output is dependent on this kind of weight, and this weight is also dependent on this one. So this is how the things will be happening. Okay. Yeah, guys, you can direct this kind of queries, okay, to the support mailbox. They will be try to understand. Okay, by using the chain rule, guys. Okay, try to understand using this chain rule. They will be able to update the weights, and try to understand when I'm trying to canceling this function. Again, I am trying to achieve the same formula. Okay, so that's how the weight updation will be happening. In the back proportion, it is going back this way, and they're trying to update all the weights. Okay, and this weights is nothing but calculated by using new weight is calculated using the old weight minus learning rate into the derivative with respect to the loss function. This is how the new weight will be calculated. What is our aim? And why? What is this learning rate? Learning rate means if I am trying to catch a weight, which was my old weight over here, then I have to move to this minima point, right? Where the derivative of loss function with respect to weight is 0 or almost 0. So in order to move there, I have to take steps, right? Different steps. That steps are called as learning rate. At what pace of change? At what pace of change I'll be moving down? That is called as learning rate, and that will be multiplied by our loss function with respect to weight. Okay, that's how the new weights are calculated. I guess in artificial neural network explanation, all the explanation of the chain rule and everything is given. This weight in fact depend on this output depend on this weight, and this weight in fact depend on the prediction. Okay, that's how the chain rule is there. So that many derivatives has to be added. If I'm trying to calculate this derivative, then I have to calculate the derivative with respect to this weight, then respect to output, and that output again with respect to y hat. Okay, this is how the going back. That's how we are trying to go back. Okay, go back to till here. That is why it is called as chain rule. I think everyone understood what is chain rule. Now try to understand, guys. Whenever I am trying to create a recurrent neural network, at that time I will be having some sort of problems with the recurrent neural network. What kind of neural network problem? That is vanishing gradient descent and exploding gradient descent. In vanishing gradient descent, try to understand when I am trying to move layer by layer, okay, layer by layer. At that time, whatever the new weights are there, okay, new weights, these new weights will be almost similar to the old weights, almost similar to weights. Why this is happening? This is happening because of the sigmoid function, and we are trying to create a loss function multiple times, right? This derivative function of loss with respect to weight, multiple times we are trying to take this derivative. Can you imagine that what is the difference and why this is happening? Vanishing gradient difference problem happen because of the sigmoid function, and we are trying to take a derivative of loss with respect to weight many times, right? Whenever we are trying to take the derivative of loss function with respect to weight, this is let's imagine this is our sigmoid graph. This lies on the sigmoid function like this one, and this is between 0 to 1, and let's say somewhere here it is 0.5. Okay, and whenever I try to create a graph which is for the derivative function of the sigmoid function, that will be lying somewhere here. Okay, this will be between 0.25. So whenever I try to calculate the loss of activation function, that loss will be lying between 0 to 2.5. So when I am trying to take derivative many times with respect to the sigmoid function, maybe my old weight, let's take example, my formula for the weight is like my new weight will be depending on the old weight minus learning rate into derivative with respect to loss function of this weight. So this derivative I'm trying to calculate, right, using the learning rate. Let's say my learning rate is like this one, and this derivative I told you what is my derivative range for sigmoid between 0 to 0.25. So if I trying to take this value derivative many times, maybe I will be left with the value like say 0.2. If I multiply this for 0.2 into 0.1 learning rate, and my old weight is say 5. Okay, my old weight is 5. Then what will be my new weight? New weight will be something somewhere like somewhere between like let's take example. If my old weight is new weight old weight is 2.5 multiplied by the learning rate. Sorry, let me clarify and write it again. Let's say this is my new weight, is depend on the old weight minus learning rate into derivative with respect to weight, and trying to substitute the function, and my derivative lies between 0 to 2.5. Let's take example. I try to put in some values over here. Let's say my old weight is, let's say, 2.5, then minus learning rate. Learning rate is, let's say, 1, and then multiplied by whatever value I getting for this range. And when I'm trying to take a multiple times this derivative of loss function with respect to weight, like this one, I'm trying to pass through layer by layer, layer by layer, layer by layer, and trying to take the derivatives, right? So in order to update the weights, at that time, what happens is that derivative becomes very small. Let's say derivative become like something 0.04. Then whatever calculation I'm trying to calculate, 2.5 minus 1 into 0.4, that will be coming like 2.46. Okay, 2.46. And what was my old weight? 2.5. And my new weight becomes, W new becomes 2.46. That means very negligible difference, right? The difference between the old weight and new weight is not that significant, and because of which my neural network, whatever recurrent neural network is there, it is not able to learn, right? Not able to learn, or not able to reach to this minimum point where error is 0. Okay, so that is the problem with the recurrent neural network having vanishing gradient problem. And exploding gradient problem don't have to do anything with the sigmoid function. It has to do with the derivatives with respect to loss. Again, whenever I am trying to calculate derivative, sometimes this derivative become very high. The value become very high. So in that case, what will happen is same thing. If I try to calculate the derivative loss function with respect to the weight, and I'm trying to update my new weight, at that time, what will happen is this derivative becomes very high. Let's say my old weight is somewhere between 0. Let's say my old weight is like 5, and this loss function will become somewhere like 120. And how it will become 120, all that calculation I will have to try to create, because that we already discussed in the previous lectures of the artificial neural network. If you want, we can go back and check that kind of videos. Let's say my old weight is 5, and whenever I try to take the loss derivative of loss with respect to weight, that will be somewhere around very high, like 120. And if I try to multiply this, it will become like around a very high value. Okay, that is multiplied minus again learning rate and everything. And whenever I try to calculate, if my original weight is 5, let's say my hypothetically my new weight will become like 120. And if this kind of weight changes is there, then in the case of the gradient descent, where I'm trying to calculate weights and biases, and here is my error, and trying to reach to 0. Okay, so what graphically what will happen is, graphically, if I started with this point, then it will be moving directly here, then here, then here, then here, then here, then here. So it will never try to reach to this 0 point. So that is what called as exploding gradient descent problem. And because of that, again, it will stop learning. It will stop learning, and will not able to understand the new weights, or able to understand the new weights or update the new weights. That's the entire intuition, guys, why it will not able to understand the things. And that are the limitation of the recurrent neural network. Okay. LSTM, I will not try to discuss, guys, today, because I know it is only 10 minutes left. Yes, guys, the vanishing gradient problem is solved by the ReLU. Okay, but because the ReLU, try to understand how it is solved. Because ReLU try to give you value somewhere between 0 to 1, max of 1, right? And because of that, it will not give you whatever derivative is there, it will not be between 0 to 0.25. So it will be able to learn or give you more weights. Okay. So LSTM, I wanted to start today, but I will not go for the LSTM, recurrent neural network. So what we can do is today, since I have left with a very small amount of time, so within 10 minutes, at least we will be able to understand what is word embedding. Then tomorrow we'll try to understand everything. Word embedding concept is very simple, guys. So we can understand that concept. And tomorrow I will try to show you with the deep neural network. So what will be the implementation of this word embedding using the deep neural network, and also the implementation of LSTM. Okay. Word embedding, try to understand what is word embedding. What happens is that I told you that whenever we are getting this kind of sentences or words, okay, sentences of words, we try to tokenize them. And then after tokenizing them, what we have to do is we have to convert them into the vectors, right? We have to convert them into the vectors. Then on the basis of the vectors only, we'll be able to understand the things, or we'll be able to make them understand in our algorithm, right? For that purpose, this concept of word embedding comes into the picture, right? And then what is the problem with our normal TF, IDF, Go model, right? What happens is if there are any semantic similarity, like there are two words which are similar, like love, like this kind of words are similar, then TF, IDF for this kind of bag of words model, they will not able to separate these features, okay? So there is no such connection or recurrency exists, right? For that purpose, whenever I am trying to say that I like you or love you, this kind of complexity features, according to the TF, IDF or Go will be not be same, right? But in fact, when I try to understand the language or speech, they are similar, right? So I should be able to get a connection between them. So for that purpose, we have to do a word embedding, right? Word embedding is what the concept of the word embedding, try to understand it. It's a very simple concept or very powerful concept that what we're trying to do. Imagine that whenever I forwarded this kind of sentence, right? This kind of sentences is there, right? First thing, when I try to do word processing or word embedding, at that time, what I have to do is I just use first create a vector, right? I have to create a vector first. In order to create a vector, right? What I have to do is I have to represent these words, okay, these words in form of some numericals. And so for that purpose, what will I do? What what technique I will be using, that will be like one-hot encoding. One-hot encoding. Using one-hot encoding, what happens is whenever I am trying to give you like why our CF idea for the other bag of word model or 3-gram or n-gram, why they are not able to understand the relationship, or they're not able to understand the whether there is any similarity, okay? There is any similarity that I'll try to explain you, that why they are not able to understand. Whenever we are trying to convert the word to vector, right, or numerical form, we are using one-hot encoding, right? One-hot encoding. In one-hot encoding, what is happening? Whatever the word is there, right? First, you need to declare the vocab size, right? Whatever is the vocabulary size. Let's say my vocabulary size is 10,000. That I am trying to create a dictionary of 10,000 words. Let's imagine 10,000 words. So my maximum words will be 10,000. That's what I'm trying to say. Then once I create my vocab size, okay, vocab dictionary size, then I have to create using the one-hot encoding technique. One-hot encoding, what it does, whatever word is there, that word will be shown as 1, and remaining all words will be shown as 0, right? This is what the one-hot encoding is there, right? Everyone understands this thing. So in one-hot encoding, what we're trying to do is whatever word is there, right? That word will be assigned some kind of index. Some kind of index. Let's say when I'm trying to create any vocab or any kind of vector, right? This is my vocab vector. In that, if I'm trying to say love, that love word will be stored, and it then what is my size length? Let's say it is 10,000. 10,000, right? So there will be numbers like 1, 2, 3, 4, 5 up to 10,000. And then if I try to take a word like love, that will be stored somewhere here. Love will be, and let's say 5,000 index. Okay, 5,000 index. Okay, and then let's say there will be a word like and love. Okay, that will be stored somewhere around 6,000 index. This is how my entire words will store in terms of the vocabulary, right? In vocabulary. And then when I am trying to perform a one-hot encoding, guys, try to understand, this is very super important concept. No, it is very simple, but it is very important that if you try to understand it correctly, you will not feel any difficulty. So when I am trying to understand using the one-hot encoding and everything, right? So whatever word is there, like, okay, in this word, let me use a brighter color, like and love. How they will be represented using one-hot encoding? Like it will try to show you 0, 0, 0, 0, and at what index my love is standing? 5,000, right? By 5,000 index, it will show you 1, and again remaining everything it will try to show you 0. Again, similarly for love, it is lying at a 6,000 index. So 6,000 index, it will try to show you 1. And for all the indexes, it will try to show you 0, 0, 0, 0. So when I am trying to compare this kind of vector, even I use a cosine similarity or some other similarity and try to compare this kind of vector and try to perform any multiplicative operation and addition operation, obviously I'll not able to understand the significance between them, right? Because it is very difficult to analyze using this kind of 1-0 representation, right? Whether this word like and love are similar, but this is what is happening using the one hot encoding, right? One hot encoding, or whenever I try to create a simple embedding, right? For that purpose, there is special word embedding layer exists. Embedding layer exists in the keras, okay? In the keras, which they are trying to show you using the feature representation. Using the feature representation and using the different techniques where there could be features along with the words. I'll try to show you what I mean. Okay. So we understood that first, whenever I try to create a word, I created a vocab size. Let the vocab size was from 1 to 10,000, and then using a one hot encoding, I'm trying to convert a text. Okay, convert a text into the numbers. But whenever I try to compare these vectors, I'll not be able to understand any similarity on anything between them, right? Between that words. So in order to avoid that, or in order to create a better word embedding, also again one more problem that I will not be able to find the similarity. And also, if you look at the dimensions, okay, look at the dimensions. Again, it is huge. Let's say if I have an entire words of 10,000 size, then tell will be 10,000 dimensions, because using this 10,000 dimensions, it will be representing my text word, right? Text word. That's again the problem. These both problems remain, right? So in order to overcome that, we are using a embedding layer in the keras, which will be able to give us a better understanding, or which will be able to give us a similarity, as well as it will be able to reduce the dimensions. Okay, reduce the dimension. How? Try to understand. Yes, guys. So we call it as sparse. Okay, correct word, correct thing. Right. Whenever we are trying to perform this kind of things, it is called as sparse matrix, because there are more zeros and only one ones. So that kind of things is called a sparse matrix. Sparse matrix. Okay. Sparse matrix is there, plus the dimensions very high. So what we are aiming for is to create a dense matrix and less dimensions. Dense matrix means there will be more number of ones. How more number of ones will be coming, that I will try to show you with these examples. Okay. Usually previously what was happening in the between range of 0 to 10,000, there will be only one and all will be zeros. So it becomes very sparse matrix. So we have to do our whole aim using this embedding layer is to convert these things into the dense layers and less dimension. Okay, less dimension. That's why we are trying to create this kind of thing. Try to understand that how this will be done. So what we do is like here in the columns we are trying to take the words, or take an example vice versa. In the rows we are trying to take the features. Feature representation. It is called as feature representation, guys. Feature representation. Feature representation using the word embedding. Okay. So we are trying to take a feature and then we try to pass the words. Okay. Pass the words. Feature like living being, penile, human, gender, royalty, verb, and plural form. Okay. This kind of features we are trying to take, and then we're trying to compare the words. Like they say, I take a word, first word as cat. If I take a cat, whether it is a living being, yes. So I will try to give a marks accordingly. So I will try to give a score accordingly. Whether it is a feline, okay, correct. It is a feline feature. If it is a human, no. If it is not human, then I will try to give a less marking. Okay, okay. Accordingly, whether it is royal, cats could be royal, right? And then verb 0.3 and plural 0.20. So according to these features, I am trying to judge these words. Okay, and then I have tried to do the same thing for dog, for house, for kitten, and then I am trying to convert this kind of words using the word embedding. Now, if I try to create a feature-wise representation, what will be happening? First of all, whenever I try to create one using the one hot encoding, all things were looking like this one. Very huge matrix were there, 10,000 matrix plus number of zeros plus ones, only ones, right? That it was creating a sparse matrix. Sparse matrix and dimension were like 10,000. But if you try to look at these things, within, like, say, how many features I'm using? 1, 2, 3, 4, 5, 6, 7. Like, using the 7 dimension, I'm trying to represent these words, right? All these words. So this could be a better example how we can reduce the complexity of the words or reduce the dimensions and make them more dense. Now this is dense matrix, right? It is less number of zeros. It is filled with the all the numbers, and this is how it will be helpful. And if even further, if I try to reduce them, okay, try to reduce them this dimension or try to show them on the graphical representation, and then you will be able to understand that how it will be help us to understand the similarity is this way. Whenever I'm trying to plot them or create this the 7 dimension to 2 dimension, and then I'm trying to plot them, then the cat and the kitten will be looking very similar at the similar distances, but house will be different, and the dog will be like somewhere near, but will be having a somewhat more distance from the cat, right? So this is how we try to convert, and this is what is happening in the RNN layer. In RNN layer, when we try to create the word embedding, okay. So we understood that right from very high dimensional sparse matrix, we try to create a dense matrix and less dimension this way by using feature representation. And then even try to, when we try to visualize this kind of dimension, we'll try to able to understand the similarity between the words, okay, similarity between the words. And this is what the entire embedding layers is giving us. Or try to understand this way, guys. Last example, I know the time is done. Last example, you should be able to understand that whenever I try to create using this kind of matrix, whenever I try to create a matrix for man, and when I told you that it will be able to identify the similarity, and I would like to give you an example for the same. Okay, whenever I try to give you a similarity, and I'm trying to show this using the feature representation, right? Feature representation, and feature will be like gender, like gender will be like there, whether this man. I'm trying to take an example of man and woman, right? Man and woman, and then I'm trying to create a word embedding matrix for them. At that time, trying to understand, I'm taking a feature like gender, feature like human being, feature like royal, right? At that time, there will be scores, right? For men, there will be score for gender, yes. Gender is there, so there will be score like 0.7. And similarly, women also have gender 7 or 6.5. Just hypothetical example I am trying to give you, okay, here. And then also they will be having like humans, right? 0.9, both are humans, 0.9. Then whether they both are having like similar example with respect to the living being, house, or any kind of other vectors like we have seen, right? Royalty, right? So if they both men and women can have a royal thing like king and queen, right? So they can be king and queens also. So there will be more probability for that, right? So when I try to compare, okay, when I try to compare these matrices, more where they will like look like same, right? The values will be almost same. Or whenever even I try to subtract the things or multiply the things, whatever matrix I will be giving, within that I will be getting less zeros and more ones, right? Less zeros and more ones, less zeros. Zero means there is no change. There is no change means there is no sorry, opposite, right? If there is a difference, that will be getting 1 1 1 if I try to subtract or try to do same things, right? Or then when I am trying to perform addition or subtraction, if there is zero means there is a not much change, that means both are same, right? So by using this kind of matrix multiplication or this kind of addition rule or operations, I'll be able to understand when I'm trying to convert a man and a woman, or let's say for that purpose king and queen, into the number of vector representation, right? And in that vector representation, I'm trying to subtract this matrix or add this matrix or multiply. At that time, whatever the resultant matrix will be there, that will be looking very similar, like king and queen and man and woman matrix will be matching. So on that basis, this embedding layer try to give us the similarity, and then it will try to create and bring down the matrix to a smaller dimension. Okay, and that is what the entire intuition is, guys, there. Okay, for the word embedding, I hope you guys are understood this. And what are the challenges with the TF-IDEA or backup mode, right? So they are giving like a very sparse matrix, like 1 to 10,000, and within that they are giving encoding like this one. But this is able to give you like within like say 10 dimension only. It is able to give you the things. And also the whenever I try to perform a cosine similarity or try to perform multiplication of the matrix or try to compare this matrix, that will be like similar to each other, right? So on the basis of that, you will be able to understand the similarity as well as you will be able to reduce the dimension And this is how it will be helpful in order to perform the recurrent neural network series sequence to sequence task. Okay, that is called as word embedding. Practical implementation, I will try to show you. Very simple practical implementation is there. And then we'll try to also discuss on the basis of the recurrent neural network. When we saw that with the recurrent neural network, we have a problem of the vanishing gradient descent, right? Vanishing and exploding gradient descent. So how to overcome this problem? We have a new network called as LSTM. So we'll try to understand what is long short-term memory and how it is having a memory cell within it, and what is the entire architecture. So that we'll try to understand. Then we'll be able to jump to a multiple LSM, or we'll be able to understand what is gated recurrent neural network, and what is the multi-directional, bi-directional RNNs are there, how the relation is there, what is sequence to sequence is there, all these things. And within sequence to sequence processing, we'll be able to understand the encoder-decoder model. Encoder-decoder model. Okay. The practical implementation of this word embedding layer using the Keras, I'll try to discuss this notebook tomorrow, and also I'll try to discuss how to perform the fake news classification. Fake news classification. So there will be more and more of practical session tomorrow, and we'll try to also understand the LSTM. All right, guys. I hope you enjoyed this session. You understood. I know there was a very heavy topics which were discussed. Recurrent neural network, how the things works upon, what are the multiple operations happening, how the forward propagation, back propagation happens, and all the stuff, and how it is actually different from the normal neural networks, and what are the limitations, what are the advantages, all those stuffs we have learned. I hope, guys, just quickly give me your feedback that whether you guys were able to understand it correctly, whether you need any explanation, further explanation. So looking at your feedbacks, I'll try to prepare tomorrow's session again to inculcate more and more of your feedbacks. Okay. So hope you guys understood the recurrent neural network. Enjoy this session. I know it was a bit complex session, but tomorrow I will try to show you and try to make it more easier when I try to make a code walkthrough for the same. All right, guys. So quickly ping me your feedbacks, and then try to punch in some feedbacks, or try to give me some feedbacks quickly within a minute or so. And if you still feel, if you have any questions or something like that, try to punch me immediately. Within next 1 minute, I will try to close this session. I know we're already late for 7 minutes, but we need to cover these topics. Okay, it was urgent to cover these topics, so we can go back and try to implement these things in the deep learning. Yeah, guys, I will ask Amar to load this material. I will try to share this material with him. Apart from that, any other feedback, guys? Did you enjoy this session? Did you feel it very complex, or it was okay? Did you feel any challenges understanding recurrent neural network? What is the use? Why we should use this one? What is word embedding? What is the typical limitation with the normal machine learning model? Why we need to reduce this word embedding, high dimension, lower dimension, sparse metrics, all the stuff. Quickly, guys, give me feedback. I know it is late, but it's no harm in giving feedback. So try to share your thoughts so I can close this meeting very quickly. Tomorrow will be again a very good session. More of practical implementation, guys. All right, guys. Any suggestion, any thoughts? Quickly, guys. I know it's late. Anything else, guys? No suggestions, no thoughts, anything else? No queries, guys? All right. Okay, I feel that everyone is comfortable. I know it's heavy to digest. Feedback link is already given, guys. Do feel the feedbacks for the day. Okay. All right, guys. Then I will take it as yes, that there are no more questions. So thank you very much, guys. Let's conclude this session and let's meet tomorrow to understand LSTM and all the practical implementation. Okay. Thank you, guys. Thank you for the feedback. Okay. I'll try to share this, all the PPT and everything on notebooks which we shared. Okay, with you guys. Don't worry. All right, guys. Then I will stop sharing. I will try to conclude the session today.
Thank you so much. So guys, one announcement is there from ExcelR team. So we are done with the 3 days and two more days to go. So we have session on Saturday as well. As we have holiday on the 15th of August, so we are going to extend on Saturday as well. So please be available and block your calendar for the same. Thank you. And one more thing, I already shared the attendance link in the chat box, in the Zoom and YouTube as well. So please mark your attendance and share your valuable feedback as well. And if you are facing any difficulty to access the LMS, please drop an email to edl@excelr.com. Okay. I hope it's clear. Yes, and as Vikas sir already confirmed that today we'll upload the material for sure in the LMS.
Yeah, I'll try to share this material, guys. It will be available then. Backend team will upload it. Okay. All right, guys. Then thank you very much, Amar.